In example 3b, we are now going to sketch in the y-axis symmetry for both of these graphs. So here, the hint is imagine folding the sheet of paper along the y-axis. Where does your graph end up? Okay, so we're going to do this the same way, except now we're just folding along the y-axis. So let's start with the graph on the left here. I am going to continue to track the old points versus the new points. So here we go, my old points. We know they are located at -8, +3. And then the top point here that's emphasized is located at -6, 7. And then our last called out point here is -4, 0. And let's see where those guys end up. Okay, so we will make a list of new points. So imagine we're going to fold our sheet of paper along the y-axis. Okay, where does each of these 3 points go? Okay, remember, by moving each of the 3 emphasized points, that will move the entire graph. All right, let's start with -8, +3. Okay, this time, since we're folding along the y-axis, we're going to draw towards the y-axis. Okay, again, count boxes. This point is 1, 2, 3, 4, 5, 6, 7, 8 units to the left of the y-axis. So when we fold the sheet of paper, it's going to go 1, 2, 3, 4, 5, 6, 7, 8 units to the right. So it's going to end up here at 8, +3. All right, let's do the same for -6, 7. This point right here at the top of the triangle, it is 1, 2, 3, 4, 5, 6 units to the left of the y-axis. Fold the sheet of paper, it's going to go 1, 2, 3, 4, 5, 6 units to the right. It will end up at 6, 7. And then lastly, let's look at the point at -4, 0. If we flip it over the y-axis, it will move here. Okay, we're going to count boxes. This point is 1, 2, 3, 4 units to the left of the y-axis, and now it's going to go 1, 2, 3, 4 units to the right. It will end up at 4, 0. All right, so there we go. Our 3 points have moved. I'm going to erase these lines that helped us get there. Okay, and now we just need to connect the dots. Okay, remember what I told you to do. You want to go from left to right and connect with the same shape. Okay, again here, each of the emphasized points is connected with a line. So we're going to go from left to right. We're going to start with 4, 0, that point, and we're going to connect it with a line segment to the point at 6, 7. Okay, and then we will go from 6, 7 and connect that point to 8, 3. Okay, and there's your graph. If you fold your sheet of paper along the y-axis, along that yellow line, the blue graph is going to lie on top of the green graph. Let's try this particular graph. Okay, it's going to work the same way. My old points here are -8, 6, and 0, 5, and 8, -2. Let's fold our sheet of paper along the y-axis and see where those 3 points go so that we can move the whole graph. All right, let's begin with the point at -8, 6. Okay, count boxes towards the y-axis. This point is 1, 2, 3, 4, 5, 6, 7, 8 units to the right, or sorry, to the left of the y-axis. So we're going to fold the sheet of paper. It's going to go 1, 2, 3, 4, 5, 6, 7, 8 units to the right. So it will end up at 8, 6. The point at 0, 5, it is on the y-axis. So when you fold the sheet of paper along the y-axis, or the yellow line, it's going to stay put. Okay, it's not going to move. So it's going to stay at 0, 5. Lastly, let's move 8, -2. This point is to the right of the y-axis. Okay, so we've got to draw boxes back to the y-axis. Okay, this point is 1, 2, 3, 4, 5, 6, 7, 8 units to the right. So when you fold the sheet of paper, it's going to go 1, 2, 3, 4, 5, 6, 7, 8 units to the left, and it will have a new home at -8, -2. Okay, so there's your list of new points. So we've moved the 3 important points, and so now the entire graph will move as a result. I'm going to remove my intermediate lines here so we can have a clearer picture of what's going on. You need to connect the dots from left to right with this curve shape. Okay, so we're going to do something like this. Okay, so if you fold your sheet of paper along the y-axis, that yellow line, the green graph will lie directly on top of the blue graph. Okay, now it's time to compare our old points versus our new points to see coordinate-wise what is really happening with y-axis symmetry. Okay, well, let's start with the left graph here. If you look at this, your y coordinates stay the same. So you've got 3, 3, 7, 7, 0, 0. It's the x coordinates here that are changing sign. We go from -8 to +8, -6 to +6, -4 to +4. Okay, same thing is happening to the graph on the right. Your y coordinates are staying put. 6, 6, 5, 5, -2, -2. No change in the y coordinates. It's the x coordinates that are changing sign. You go from -8 to +8. 0 is irrelevant because it doesn't have a sign, but at the bottom point, 8, +8 goes to -8. Okay, so I'm going to go ahead and write down this observation for y-axis symmetry. If you start with any point, and I'm writing it abstractly, a point with coordinates x, y, for y-axis symmetry, what's going to happen is that the y coordinate is going to stay the same and your x coordinate will change sign. Okay, so to translate this in words, this means that x changes sign and y stays the same. Let's go ahead, let's jump over to page 6 and jot down that observation. Okay, so for the second bullet point here, if a graph has y-axis symmetry, then for every point xy on the graph, that point xy is going to get sent to -xy. Y stays put, x changes sign. Okay, so if you were sketching y-axis symmetry, okay, you take a point xy, okay, that point is going to get sent to -xy. Okay, you can also think of it if you have a graph and you're trying to figure out if it has y-axis symmetry. If you look at a point xy, you need to see if the point -xy is also on the graph. Okay, if it is, then chances are that graph has y-axis symmetry. Okay, let's jump over to origin symmetry.